Thank you for joining us this morning on this webinar on IEC support. So this is the fourth part we've done of this. It's mainly around UDFBs. We will have other parts coming up as well on this, but for now, we'll go through this one. It's roughly about 15 minutes or so. And if you have questions, you can just drop them in the panel.
Welcome to today's tutorial. Let's get started. Let's have a look at today's agenda. Today we're going to be looking at IEC 61131 user-defined function blocks and how to use them in Cscape. We'll have demonstrations throughout, and as always we'll finish with a Q&A session. This is a follow-on from our previous webinar on IEC support where we looked at subroutines, so make sure you go back and watch that if you haven't seen it already. You can view these in the webinar section on the Horner website. Before we look at UDFBs, let's have a quick look at the subroutine from our previous IEC webinar. In this subroutine, we are calculating the volume for 3 tanks using variables for our radius and liquid height and applying a formula to that to calculate our liquid volume. We gave our variables a dimension of 3, creating an array of variables for each of our 3 tanks. We also did an any to real conversion on the integer variable for our liquid height so it could be used in our graphics for a slider. Suppose we now wish to add functionality to this subroutine where we'll also want to obtain the maximum and minimum levels of the volume over a period and also track at what rate the volume is currently changing. One way to do this is to add arrays to hold the previous minimum and maximum as well as a previous volume to generate the rate of change value for each tank. We could pass the tank number as an additional parameter to the subroutine to keep these arrays updated. However, a much more elegant solution is to rewrite the subroutine as a user-defined function block, or UDFB. Since UDFBs have instantiated data, the additional arrays are no longer required, as the minimum, maximum, and rate of change become outputs from the UDFB, and so each instance of the UDFB will have its own set of these variables. Let's see the user-defined function block being called in a main loop FBD diagram. 3 instances of the block exist. We've used a common B reset signal which will reset maximum and minimum readings for all tanks at the same time. The additional maximum, minimum, and rate of change variables have not been used in the logic, but they will be available for use in the graphics for this program. In our first demonstration, we'll show how to create and use that user-defined function block that we just showed in our slides in Cscape. We're now going to replace the subroutine we created for the tank volume calculation with a user-defined function block, where, as well as calculating the liquid volume, we're also going to maintain the minimum and maximum volume during a time period and also track how quickly the liquid volume is changing. To start, I've renamed the subroutine as unused sub to stop the original subroutine being accessed, and I've added a new module in the UDFB section which is created as structured text language, and I've named it Tank Calcs. I've pre-created this module. There's not too much to learn about the editing because the module is just text. In terms of module text, the first calculation line is identical to the subroutine version of this. The liquid volume is equal to pi times the tank radius squared times the liquid height. We've then added some new logic to maintain the minimum and maximum volumes, and also logic to maintain a variable storing how quickly the volume is changing. The first thing I've done is to add a new input boolean b reset and new outputs to output the maximum and minimum volumes seen since the readings were last reset, as well as an output with the change in volume seen over the last 1 second, which is of course the rate of change of the volume. Again, first I've created an additional input variable b reset, which will cause the minimum and maximum volume readings to be set to the current volume. Without this, we'll just keep updating the minimum and maximum, likely until they reach tank full and tank empty. So we need to reset these values at appropriate points, maybe once an hour, once per day, or once per shift. We then have some logic. If the maximum volume is less than the current volume, we have a new maximum volume, and we set the maximum volume to the current volume. Similarly, if the minimum volume is greater than the current volume, then we have a new minimum volume, so we set the current volume as the minimum volume. Finally, we use the 1 scan per second signal we generated earlier using the rtrig function driven by the 1 second timer system bit sys4 to allow us once a second to update the volume rate of change variable. We do that by subtracting the last volume from the current volume. A facility in the intermediate language and structured text languages, which are written in text rather than graphically, that we are using here, is the ability to document your code with comments. So the comments are just sections of text ignored by the compiler, and we indicate to the compiler which bits of text are comments by either inserting a double backslash, in which case the remainder of that line is commented, or using open bracket star to indicate the start of a comment, along with star close bracket to indicate the end of the comment. Comments are shown in green text by default. Both forms of the comment are used here. Comments can be used to document your text for ease of interpretation in the future, and also to temporarily disable sections of the code when debugging. So that's the new tankcalcs UDFB. We're now going to look at replacing the previous subroutine form of that in the tanks main loop module. If we go back to the tanks function block diagram, we can see the original logic. The first thing we'll need to do is remove the original subroutine form of the calculation. I left the original subroutine as unused sub to highlight the fact that if we now look in the project set in the project toolbox, we can see both a subroutine, unused sub, and the new UDFB tankcalcs. We can see that the two different types, subroutine and UDFB, have different icons. Again, the UDFB is indicated with dots within the function block representation, which indicates that the block will need to be instantiated rather than just dragging it into the diagram. We're going to drag and drop the tankcalcs variable from the project toolbox into the tanks variables. I'm going to repeat this 3 times for the 3 different tanks. An alternative would be to drag and drop it once and again dim it to 3, but this time we'll have 3 separate blocks and name them tank 1, tank 2 and tank 3. Once instantiated, we can take the 3 UDFBs and drop these into the tanks main loop module. I'm going to stretch the size of the UDFBs so that the input and output names are all visible. I will cut to this point now. Once that's done, I can immediately reconnect all the variables to the inputs and outputs that they were connected to previously, since the volume is going to be calculated in the same way as previously. Again, I'll cut to this point now. Now, I'll tidy up the logic to make all the connections simpler. Although we've assigned outputs for maximum, minimum, and rate of change of volume, I'm going to use those in the graphics part of the program for now, and so we don't actually need to make any connections for these unused in the logic outputs. We could have left them as private variables for the UDFB, but making them outputs means we could make use of them in the logic later if required. We do always need to drive the inputs to a UDFB, however, so I'm going to create a B reset variable and drive the reset signal of all 3 UDFB instances with that and map that to K1, so when we press function key 1, the B reset variable will become true. Dragging and dropping that onto the diagram, I'll link that to the B reset signal on all 3 UDFBs. That's legitimate, as a variable can drive as many other variables or function block inputs as is required. The reverse is not true. A function block input or setting a variable can only be done from one source. Our diagram is a bit difficult to read now because of all the lines crossing. We can rearrange that for clarity. To do this, click on the line and drag and drop segments as appropriate. To make things even clearer, Use the connection tool in the toolbar to indicate where lines are crossing where they are physically connected. After I make those connections, that should be everything I need to do for my user-defined function blocks complete. I'll then do a quick error check, which shows that there are no errors in our program. In this next demonstration, I'll show you how to use graphics with that user-defined function block we just created. I've made the logic up for the UDFB phase, so now let's look at what we might do for the graphics for that. This will be based again on the subroutine version of the tank situation. So let's open the graphics. I'm going to split it so that I have 3 screens for 3 tanks. I'll start by getting rid of tank 2 and tank 3 by selecting all the items for that each in turn with the control key on your keyboard held down. This allows us to select those and delete them. Now I'll select all and I'll copy the fields on this screen. Then I'll move to screen 2 where I'm going to paste them back in. The liquid height I will leave as it is. I will move the radius setting out of the way because it's different to the others in that it's going to be editable while the rest are just display only. Then I'm going to take the field I've assigned for my volume and put it at the top of the screen. And then I'll widen that. I am going to copy and paste this 3 times, so I will have fields for the current volume, the minimum and the maximum volumes, and the rolling average of how the volume is changing. Tank 1 volume will be as it is. I'm going to go to this first field that I pasted. I'm going to make this my tank 1 maximum volume. First, I'll go into the legend and name it as my tank 1 maximum volume. Then I'm going to go to my variables. The data from this will come from tanks. In tanks, I'm going to select tank 1 and then the maximum volume. Next, I'll go into this next field I pasted, which I'm going to make my minimum volume. Similarly, for the minimum volume, I will go into tanks, then tank 1 and select minimum volume. Again, I'll name it in the legend. After this, I'll go to my final pasted field, which I am going to use for the tank 1 volume rate of change. This is going to be in millimeters cubed per second. Again, I'll go into tanks, then tank 1, and I'll select the volume rate of change variable. Again, I'll change the engineering units to millimeters cubed per second, and then I'll change the legend appropriately, which I'll do quickly off screen. Now I'll quickly adjust the look of my screen slightly. I'll move the radius field more central, and I'll lower the height of the slider for my liquid height. Then I will add some text to show clearly this is for tank 1. I can change the font and color of this text. I'll select a large font size so it's easy to read, and then I'll go into text color and select a new one that's readable. Now I'll move that text so it's more central. Now I will set the screen background. I can change the color and I can add a gradient to this color. I'll go into background color and I'll choose this one. Then I'll enable background gradient and I'll choose another color. If I go into more, there's a lot more color options available. I'll make it slightly darker and see how that looks. I'm going to change the color of my text again to make it more readable. Finally, I will add a screen jump. I'll move the radius field slightly to make room for this. And then I'll drag and drop the screen jump onto the screen. Then I'll configure that screen jump. In the attributes, I can make this a home button. This will take us to screen 1. In the legend, I can remove the text which will display a home icon instead. I can then duplicate this screen for my other 2 tanks, changing the variables, legends and text fields appropriately. I would then make screen 1 my home screen with jumps to each of my different tank screens. Now I'll show what that could look like on the OCS itself. Here I have a home screen that I've created with each of the 3 tanks. I'll go into the screen for tank 1. Here I have my data fields displaying my volume, my maximum and minimum volumes, and my volume rate of change. My volume is being calculated using the original calculation from my subroutine and using my liquid height value that I can change with my slider and the tank radius that I have inputted. Now I'm in my screen for tank 2. Know that the maximum and minimum volume both start at 0, and of course, as I increase my liquid height, the maximum volume increases to the max volume reached for this shift. If I press function key 1, my B reset variable is triggered and the shift starts again from the current volume. I'll show this again now. So if I press key 1, the shift starts again from my current volume and my shift minimum volume is now higher as a result. Thank you for joining us for today's tutorial, and the Q&A session will begin shortly.
Okay, hopefully that was all very beneficial to you. I'm not seeing any questions currently, so I shall bring you across. And you should all hopefully see my screen now. So in the next 2 weeks, we have part 1 and 2 of recipe management, followed by function blocks and hands-on with Cscape protocol into the start of May. As I said earlier, there will be another part to this IEC section of videos. We'll put up the date in this section here on the site when it is closer to the time. And as always, if there's any past videos, you're more than welcome to go back and watch them all. And if there's anything that hasn't been covered and you would like covered, just drop us a mail at tech support and we'll try put one together. Other than that, if there's nothing coming in, I think we'll leave it there. Thank you for joining us this morning again, and we hope to see you again next week.